Jumping Airlines Math and History, and we're going to be taking a look at compound problems. The definition used for compound is compound means that it's combined with another object, like compound problems consist and include at least two shapes or more, because usual geometry problems we're only solving the volume of one shape, but in compound problems we're going to be solving a problem that consists two shapes. So we're going to solve a sample problem that consists two 3D shapes, and we're going to try and find the volume of it. So remember, volume is what's inside a 3D object. Like this jar is a 3D object. We're measuring what's inside the object.
1, 2, 3, 4. 1, 2, 3, 4. Now, let's see how the boy turned out.
Can I go again?
So that was the example of volume. So here is our problem.
You realize I'm taking that out of your paycheck. Seaweed surprise! Also, malted coral crunch! Also, lipids and cream.
So Patrick went to an ice cream store and he's buying a lot of ice cream. What he wants to understand is the volume inside the ice cream, because that is all the good and tasty stuff inside. That's where all the yummy and delicious stuff is. So we want to understand, what is the volume of Patrick's ice cream? So here is Patrick's ice cream. There is a hemisphere, also known as a half a sphere, and there is also a cone. This is an example of a compound problem because it has at least two or more shapes combined into it. And we're going to find the volume of both of these shapes individual, because normally we would be solving one shape for the video, but compound problems will allow us to solve the volume for two 3D shapes. Then we can combine them together to make one 3D shape. The dimensions of Patrick's ice cream is the hemisphere is the radius, and that radius is right there. The radius is going to be 3 centimeters, and the cone below it is going to be the height. This is the height of the ice cream, and the height is going to equal 5 centimeters. What is the volume of Patrick's ice cream? So, we understood that there are two 3D shapes involved in that ice cream. What we're going to have to do is write two formulas, because one is a sphere, well, a hemisphere, and one is a cone. We're going to be using two formulas. Let's start with the cone, because you have to have a cone before you put the ice cream on top. So let's solve this. So we have 3 centimeters as the radius, and the height is going to be 5 centimeters. So we're going to insert volume equals pi. The radius is 3 centimeters squared. Multiply that by the height, which is 5 centimeters. Then we get to divide our answer by 3. The formula for volume of a cone was in our past videos. So if we do the math, we have to do pi multiplied by 3 squared. So what we're going to have to do is have that 3 squared and turn that into 9, because 3 times 3 is 9. So, here's pi, and here's 3 squared. 3 times 3 is 9. Then what we're going to have to do is multiply that by pi to get a circle. What we did is pi r squared is the area of a circle. That is what's in the bottom of the cone, is the circle. So, pi multiplied by 9 by 3.14, we use 3.14, we multiply it by 9, we should get an answer of 28.26 centimeters squared. And that is our answer for finding the volume for the circle. Actually, finding the area of the circle. Because a circle is a 2D shape, not a 3D shape. So that's why we use squared, not cubed. Cubed would be for 3D shapes. Our next step is to multiply by 5. So this is our answer we got for the circle. So now we're going to have to multiply that by 5. Because 5 is going to be the height. And the circle we got last time, we're going to have to multiply by the height to get the cylinder. So, 5 multiplied by 28.26, that's going to equal 141.3. That is going to be our answer for the cylinder. Our last step for the cone is to divide by 3, because a cone takes up 1/3 of the volume of a cylinder. If you put a cone inside a cylinder in the last video, just like the last video, it's gonna take up 1/3 the space. So we're gonna have to divide this answer by 3. So 141.3 centimeters cubed. Divide that by 3. That is gonna be equal to 47.1 centimeters cubed. That is going to be our answer for finding the cone and finding the volume of the cone. The next step is to find the ice cream, because since we have a cone, now we get to add the ice cream on top of it. And that is the delicious part of the ice cream.